Assalamu alaikum. This is second lecture of Algebraic Topology, and I am going to explain in this lecture this is lemma, prove this lemma. So what is the statement of this lemma? The homotopy, homotopic or equivalence relation. So I am going to prove this lemma. So first of all, we have to prove reflexivity. So what is reflexivity? First of all, we have to know what is reflexivity. Reflexivity means for all x belongs to x such that x is related to x. Okay, so now we have a case of homotopy. So we have to prove f is homotopic to f. Okay, so let's say f is a map, f is a continuous map from x to y such that so f is a map from x to y. F is a continuous map from x to y. We need to prove f is homotopic to f. So we have so we know we need to construct a homotopy. Means there is a continuous map from x cross I to y such that h of x comma 0 we will get f, and h of x comma 1 we also get f. So how we can construct this type of map? So we will get f is homotopic to f. No explaining. So h is a map, h is a continuous map. There is a continuous map h from x cross I to y, and define h of x comma t is equal to f of x for all x belongs to x and for all t belongs to 0 comma 1. So this type of map we will get our requirement. So at h of x comma 0 we will get f of x according to this equation, and at h of x comma 1 is equal to f of x. Okay, so according to this homotopy, this map for all x belongs to x, so we get f is homotopic to f. Okay, this condition is satisfied of reflexivity. So now second condition is symmetric. Symmetric means if f is homotopic to g, then we need to show G is a continuous map from F. G is a continuous map. Sorry, F and G is a continuous map. If F is homotopic to G, then we need to show that G is homotopic to F. Means this condition is supposition. Suppose F is a continuous map x cross I from x cross I to y such that this is given such that at f of x comma 0, at f of x comma 0 we will get f of x for all x belongs to x, and f of x comma 1 is equal to g of x for all x belongs to x. Okay, so now according to this condition f is homotopic to g. This is the given condition. Okay, this is the given condition. So now we now we have to prove G is homotopic to F. So how we can prove that G is the homotopic to F? So we can construct a homotopy, like G is a homotopy x from x cross I to y. And how what is the definition? What is the construction of G? So G of x comma t is equal to f of x comma t minus 1. Oh, sorry, 1 minus t. Now we are constructing a new homotopy. G of x comma t is equal to f of x comma 1 minus t. Okay, such that, so how this homotopy work, at g of x comma t, x comma 0, so we will get f of x comma 1. As we know the definition of f, we will get g. At of f of x comma 1, we will get g of x. Okay. At g of x comma 1, according to this construction, we will get f of x comma 0. And as we know, f of x comma 0, we get f of x for all x belongs to x. And at this condition also for all x belongs to x. So we get G is homotopic to F, and this is the homotopy. There is a homotopy G. Means we have the given condition F is homotopy. F is homotopic to G and F is a homotopy. According to the given condition, then we construct this homotopy for G is homotopic to F. So what is the equation of this? G of x comma t is equal to f of x comma 1 minus t. So if we substitute t is equal to 0 at g is this homotopy, this continuous map, we will get g of x according to this condition. At t is equal to 1, at t is equal to 1, we get f of x. Means g is a homotopy from g to f. So this symmetric condition is also hold. Now we are going to next, transitivity, the last condition, the last axiom, transitivity. So what we will have proof. So if F is homotopic to G and G is homotopic to H, then we need to show that F is homotopic to H. Okay. According to the given conditions, F is homotopy. F is a homotopy. F is a continuous map from x cross I to y such that f of x at f of x comma 0 equal to f and f of x comma 1. We will get G, means f is homotopic to G according to this map, and G is a homotopy according to the given condition for x. This is a map, continuous map from x cross I to y such that at g of x comma 0 is equal to g and g of x comma 1 is equal to h. Okay. So we have to prove, we have to construct a map which we will show f is homotopic to h. So how we can construct? So let's say, let K is a homotopy. K is a homotopy. And what type of homotopic map? K of x comma t, f of x comma t, x comma f of x comma 2t when t is between from 0 to half, and g of x comma 2t minus 1 when t is equal from half to 1. Okay. So now we are checking this. F at x at t is equal to 0, k of x comma 0. So according to this condition, f of x comma 0, we will get f at k is equal to k of x comma half. So according to this condition, we are lying here. So when we substitute t is equal to half, we will get x comma 2 multiply 1 upon 2. So we will get f of x comma 1. So we get g. Now substitute again x t is equal to half. So we are lying here because 1 upon 2 also lie in this condition. So we will get g of x comma 2 multiply 1 upon 2 minus 1. So what we will get 1 or 2 divided by 2 and 1 minus 1. So we get g of x comma 0. G of x comma 0. We will get also g at g of x comma 0 according to this condition. And now we are substituting t is equal to 1. So t is, if we substitute t is equal to 1 according to this this condition, t is equal to 1. So 2 ones are 2, 2 minus 1, 1. So we will get g of x comma 1. So we will get h. So now, yes, we proved K is a homotopy from F to H according to this condition and this construction of homotopy. Okay, and we can prove this K is continuous map. K is continuous map x cross I from x cross I to y. So how we can prove? How can we show this K is a continuous map according to the pasting lemma? I will explain in next video how this K is the K is continuous map by using pasting lemma. This is a continuous map at this point at t is equal to half. At t is equal to half, we will get the same value of f and g. We will get the same value. Okay, so we proved this lemma, the homotopy. The homotopic or path homotopic are equivalence relation according to these prove this to satisfy this three conditions. First reflexivity, then transitivity, then symmetric, and then transitivity. So we proved this homotopic is a equivalence relation. Okay, means so what we can conclude according to this lemma means the homotopy or path homotopy is a equivalence relation. We can conclude f and if f is homotopic to g means f comma g both belongs to the same class. Okay, with the both maps or all other maps which is homotopic to f or g, so all the maps belongs to the same class which is f. Okay, we can conclude this is the class. In which class? What type of maps? All the homotopic maps belongs to this. Means this is the one element. Okay, Allah Hafiz. Now I am end this video and I will explain next topics in next video. Please subscribe and share this my channel. Allah Hafiz.